All right, in this lesson we are going to be looking at some word problems that involves making algebraic equations and then solving them. So here we go. The volume, which you're going to call V. So I'm going to just kind of make an equation as I go. The volume, which I will call V, equals the product. Product means to multiply. So the product I'm going to multiply. That's what this means. I will multiply pi and the square of the radius. So the square of the radius, which you're going to call r, would be r squared, and the square of the radius of the base and the height. So I'm going to multiply pi times r squared times the height. Okay, so there's your equation. That equation should look familiar to you. You just don't usually typically see it written in sentence form. Then it says find the volume if the radius is 6 centimeters, so this means that r equals 6, and the height is 15 centimeters, so h equals 15. So you will plug 6 in for r, and you will plug 15 in for h. So volume equals pi times 6 squared times 15. Okay, and so obviously that would be pi times 6 squared is 36 times 15. 36 times 15 is 540. And I'd actually like to have you leave it as 540 pi. Some of you I know really want to go to your calculators and take 36 times 15 times pi. If you do that, you're going to get about 1,696.46. But that's a rounded answer, and so I really would not prefer to have you do that. When you do volume, your answer will be in cubic units, so this will be centimeters cubed. Okay. All right, the next one, 1/6, so 1/6 times the weight on Earth, which I'm going to call E, equals, obviously is equals, the weight on the moon, which I will call M. So there's my equation right there. 1/6 the weight on Earth equals the weight on the moon. So Neil Armstrong's suit and backpack weighed about 33 pounds on the moon. So I am going to plug 33 pounds on the moon. That means that M would be 33. The question is, what did he weigh on Earth? Okay, so you will go 1/6 E equals 33. I can multiply both sides by 6. And 33 times 6 comes out to be 198 pounds. So on Earth, Neil Armstrong weighed 198 pounds. On the moon, he only weighed 33. All right, so here we go. These next ones are consecutive integer problems. They're very famous kinds of math problems. They all follow a similar pattern. You just have to kind of muddle through them. Okay, so here we go. First of all, you need to know what an integer is. So here's a reminder. An integer is all the positive and negative whole numbers, including 0. Okay, so you can't have fractions in here. You can't have decimals in here. But it's every whole number, positive, negative, or 0. Okay, so if I'm asking you to find the sum of 3 consecutive integers, sum, first of all, means to add. Okay, so sum means to add, and I am going to add 3 integers. Now, I don't know what these 3 integers are, but when I add these 3 integers together, I will get 147. And I should tell you, you guys, that on a quiz or a test, if you're doing it for me or any one of the algebra teachers, you cannot just guess and check here, just so you know. You're going to have to show us that you can write equations and solve them. Guessing and checking will not get you credit on the test, okay? So, here we go. The sum of 3 consecutive integers is 147. So let's just say that this spot right here is an integer. Forget the number down below it. Just let's call it x. Okay. What I know is that if I have 3 consecutive integers, the next integer, this one right here, is 1 spot over from the original. So this one right here would be x plus 1. Okay, you're always measuring from the original spot. Then the next integer over this one would be 1, 2 hops over from the original one. So the next one would be x plus 2. Okay, so I have three integers. I have x, and I have x plus 1, and I have x plus 2. Okay, and it's saying that I need to find the sum, which means I need to add them. So I'm going to add x plus 1 plus x plus 2. When I do that, I will get 147. Okay, and now I need to solve. So I'm going to combine my like terms. I have 1, 2, 3x, and then 1 plus 2 makes 3. Okay, subtract 3, and I'll get 3x equals 144. Divide by 3, and x equals 48. A lot of people want to stop right there, but please make sure you go back and read the question. The question is, find the integers. That means to find all three of them. Okay, so the first one is 48. Okay, remember that was this one right here. So the next one is 48 plus 1, which is 49, and then the third one would be 48 plus 2, which would be 50. Okay, so 48, 49, and 50 are my three integers that I'm adding together to get 147. Okay, these next ones are a little bit different because I'm wanting to find three consecutive odd integers. So I want you to think about this. Let's say that, and I forget the number down below, let's just say this is a spot on the number line. This spot right here I'm going to call x. Okay, now I need the next consecutive odd integer. So that would be, if it's odd, -3 is the first, that would be this one, right? I can't go to the next consecutive integer, I have to go to the next consecutive odd integer. So the first one's probably not -3, but let's pretend it was -3. If I wanted to find the next odd one, I would need to go to -1. Okay? Hopefully you can see that I made 2 jumps over. So the next consecutive odd integer would be x plus 2. Okay, and again, you're always measuring from the original spot. Then the next consecutive odd integer would be right here. Pretend it's not 1, but if it was, you could see that you would have to make 1, 2, 3, 4 hops over from the original, and the next one would be x plus 4. Okay, now again, I'm doing sum, which means I'm going to add x plus the next one, which is x plus 2, plus the next one, which is x plus 4. Okay. And when I do that, I will get -111. All right. So I have 1, 2, 3x plus 2 and 4 is 6 equals -111. So to solve for that, I will subtract 6, and I will have 3x equals -117. Divide by 3. And -117 divided by 3 would be -39. Okay, so the first number is -39. All right, then I want to think about this. This number right here is -39. When I add 2 to -39, I'll get -37. When I add 4 to -39, I will get -35. So my answer would be -39, -37, and -35. All right, and the last one, the sum of 4 consecutive even integers. Okay, so let's just find an even integer on the number line so we can kind of picture this. I am going to call this an even integer. It is. -4 is an even integer. I don't think that's the right answer. I don't think I'm at -4, but let's pretend I am. So that spot would be x. The next even one would be at -2, so I have to jump over 2 spots, right? So if I jump over 2 spots, then you can see how you went 1, 2, right? This would be x plus 2. If I jump over 2 more spots, this one right here from the original would be 1, 2, 3, 4 spots over, or x plus 4. If I go to the next even integer, I would go 1, 2, 3, 4, 5, 6 spots over from the original. You're always measuring from the original, and that would be x plus 6. Okay? So I'm adding those four integers up now. X is the first one. X plus 2 is the next one. X plus 4 is the next one. Whoops. And x plus 6 is the next one. When I add those all up, I am needing to get 140. Okay? Guessing and checking is not going to cut it, folks. You have to be able to make an equation. Okay? So I have 1, 2, 3, 4x is, and then I have 2 plus 4 is 6, plus 6 more makes 12. And then, of course, to solve for this, I will subtract 12. And I'll have 4x equals 140 minus 12, which we know is 128. Divide that by 4, and x is 32. But you haven't answered the question yet, so make sure you find all four integers, okay? So this one is 32, plus 2 more is 34, plus 4 more is 36, plus 6 more is 38. Again, always measuring from the original. So 32, 34, 36, and 38. And if you add those four integers up, you can check and you should get 140. Whoops.